Ladies and gentlemen, today we're going to be fixing an RCD fault that we've identified is on this fan here. As you can see, the lights are all on, we're all good until we turn the fan controller on. So we can turn a light on in the cupboard here. When we turn this on, that's the RCD and the switchboard tripping. This one here, this module with the test button on it is an RCD. And I'm going to break it down to you exactly what I would go through in a sequence to find exactly what the fault is on this fan. Now I've got no idea what the fault is. Could be the fan itself, could be the controller, could be the cable. So the first thing that I'm going to do is undo this metal shroud here, pull it down, make sure it's turned off, which it is. Can't turn on anyway because it will trip the RCD, and then I'll disconnect the fan motor itself, or the feed that comes into the fan here, throw it in connectors, try and turn it on again and see if it trips. If it doesn't trip, then we know that this unit here is faulty, and what I'll do is pull it apart and try and find exactly what the fault is in it. However, if it does trip the RCD still and this is completely disconnected, then we know the fault is between here in there. Sweet as. Got my ladder here. We're gonna do, see these screws on the side here, either side. Got to take one out and then this will twist around and pull down. Be aware of falling bits, make sure you locate them all, especially if you or your customer has small children. Take the next one out. I should be using two hands. One hand's just holding the camera at the moment, so it's a bit awkward. We can rotate it. Rightio. Alrighty. So this here is where the feed comes in. What do we got here? Live, neutral, L1, earth. Right, so what I'm going to do is disconnect the phase, the neutral and the earth on the load side of these connectors, and then we'll fire it up at the switch and we'll see if the RCD still trips. Sweet, so as you can see, we are completely disconnected up here. The cell 1 goes into nothing, and we'll go and liven it and see if she trips. Right, so we're back at the controller, so make sure the lights go on, power's there. And look at that, we're fine. So I've isolated the fault to the fan here. So everything, including this connector block here, is not going to trip the RCD. So there is something inside this fan which will trip the RCD. So let's give it a couple of tests. Sweet as, guys. Next thing, we're going to get our meter out, throw it onto ohms, that symbol there. Got our open loop. Make sure that these leads are fine on the meter. So all we do is touch them together. She'll make a wee tone when they're touched. First thing we'll do is test the earth continuity in it. Just make sure that, touch a random screw on here, and then touch the earth cable. We're going to get a beep. Yep, so that's fine. Now we'll check between earth and phase and neutral on here. Nothing. Nothing. Earth again. So everything looks fine at the moment. We don't have a short between phase inside the fan and the exterior of the fan. For an RCD to trip, should have gone through this earlier. So for an RCD to trip, there has to be some leakage current. So somehow earth is getting contact with neutral. Somewhere in the circuit, we've got to identify exactly where in the circuit that's happening and find out the fault. So we're testing between here and the chassis. Cool, and that's fine. So everything in this fan looks fine. The next test we're going to do, so we've used this connector block, is we want to make sure that none of these cables that come into the block, which is isolated from this, is actually in continuity with the earth here. So we'll test the earth. That's fine. Neutral. Okay, I think we've found our problem. And phase. So that's fine. So it sounds like this neutral here is getting continuity between the earth of the chassis and the neutral in there. And it looks like that screw holding the connector block between the insulating material and the chassis has somehow pierced through the plastic, and that screw in the middle there is making contact with the inside of the neutral connectors. So I'll test that this one here is not getting continuity. Cool. So what I'm going to do now is I'm going to move the neutral from here into here, connect these back up, so earth, neutral and phase in the top, and then this L1 I'm just going to have in its own connector. The reason I don't want to put all new connectors in here, and I'll still reuse these good ones, is because I don't have much room to work with, and I don't want this thing being a nightmare or a struggle to put back up. So let's chuck the phase back in first so we don't get these wires muddled up. Guys have gone and soldered it, they used to do back in the day, so make sure we clamp the screw down onto that soldered part, so that's good. Now we'll take this other phase out that we're not going to use because it wasn't used in the first place. Throw the earth into the earth one. And make sure we clamp down. That was no bloody good. What I'm going to do is strip a wee bit more off this. That's a bit of a joke. Sweet. Right, so that's a bit better there. Got a lot more surface area to grab onto. And we'll do that one up. Do the pull test. She ain't coming out. Throw our neutral into the one below it, where the neutral currently is. We'll pull off the sticker reference so no idiot confuses themselves in the future. Throw the neutral in. Always do the pull test on these cables. And then move this neutral down. Bloody thing's been in there for years, so I'll get the old long nose pliers out. Just needed 2 hands to get that one out. Anyway, slap that one in. That one's in good. Now we'll chuck a connector on the end of that. Right, there we go. Tuck that in there, tuck that in there. Now we've altered this, changed it all round. So what we're going to do is test to make sure there's continuity between the earth and the outside of the fan. We'll also just double check there's no continuity between phase earth and neutral. Chuck one lead on the screw, one on the earth. We're good. Neutral, nothing. Phase, nothing. Perfect. Right, so what we'll do, screw this back up, and then we'll go and liven this bad boy. Alright guys, throwing this cover back on, so we should be good to go. Make sure we've got our power on, all that sort of jazz. Fire up, low. Look at that. It's on high. So, bloody awesome. If you guys hadn't seen my switchboard video, recently this house was upgraded to RCDs. With an old house, when you upgrade to RCDs, or if you've got old appliances, you may find you have some RCD issues with them when you liven up. Fortunately, there should always be a way to repair them. So if you come across an RCD fault, if customer's got an issue and has rung up and said, hey look, last night this flicked off and they've left it off, flick it back on, see if it trips off straight away. If it doesn't, then it's likely that it hasn't done it before. They've plugged something in and it's tripped the RCD, then they've unplugged it and moved it somewhere else. So always just make sure you get the full history of what the hell's actually gone on, unless it's isolated to a specific appliance where you can actually work out what one it is that's causing the issues and then investigate it from there. Cheers for watching guys. Enjoy your week. So for you guys who also watched the switchboard install video, ceiling fan and the waste disposal unit were the two things in this house that we were playing up. Ended up getting a brand new dishwasher, InSinkerator and sink anyway. So there's the new one. Can't see the bloody thing behind there. That's the new one there. Saves tearing apart the old one and finding exactly what the RCD issue is. Even though it could be something quite simple, it was time for a new InSinkerator anyway. Catch you on the next one.